Good afternoon, everybody. I have a interesting equation here for you that involves rational exponents. It's a three-termed expression. It reads x minus 1 quantity raised to the 12 over 5 power plus x minus 1 quantity raised to the 7/5 minus 12 times x minus 1 raised to the 2/5. So the most salient feature of this is that all three of the exponents are rational. They're fractions: 12 over 5, 7 over 5, and 2 over 5. So this looks kind of difficult, but really it's essentially based on the notions of factoring and just a property of exponents that says if you have a base raised to a power times a base raised to another power, that's equal to the base raised to the sum of those powers. And for natural numbers, that's an easy thing to see. It's not quite as clear for rational exponents. But what you do here, it's common to regular factoring. It turns out it's very convenient to factor out the lowest exponent, the smallest exponent, which is 2/5 in this case. And how do you know? Well, it just turns out that it works out, and I'm sorry, that's the best I can tell you. It works out nicely that way, and it does so for the following reason. If you factor out x minus 1 quantity to the 2/5, now notice I left these as fractions. A lot of people at this point will just go ahead and call it 2 and call it 1. I think that's a terrible omission. You should write that down until you get used to this stuff, especially teachers. One of my colleagues didn't do this, just skipped the step, and I think you're missing out on a great learning experience for a lot of students if you leave this step out. But notice the 2 over 5, your base here, of course, is x minus 1. In other words, and this is a difficult thing to see sometimes, the base is actually a two-termed expression, x minus 1, so your b is actually a two-termed expression, namely x minus 1. And so again, we decided to take out the smallest one, and the reason is it just works, okay? I don't want to get too sophisticated on this, but if you put the 2/5 here with the 10 over 5 and add it, you get 12 over 5. Again, 10 over 5 plus 2 over 5, by this rule it says plus, right? Plus, plus, plus right there, where you're multiplying these two like bases. This is your b, this is your b, this is your exponent, this is your exponent, right? So 10 over 5 plus 2 over 5 is certainly 12 over 5 as anticipated, as expected. And also this 2 over 5 added to the 5 over 5 gives you the 7 over 5 that you see right here. And of course, we factored out almost all of this term. All that's left is a negative 12, right? X minus 1 to the 2/5 is the actual term that's present here. And this is pretty common. Like if this were just x, sometimes you would just take the x out and leave a number there. So it's the same sort of principle. Now, so again, I left it just in the fractional form for illustrative purposes. But note, I'm going to go to the next screen. 10 over 5 is 2, right? 5 over 5 looks stupid is 1, right? Well, that's the next screen. Okay. Now, so you get something, and again, this is where a lot of people would have just done this step immediately, doing that calculation in their head. Now, the rest of this is just expanding out this binomial x minus 1 quantity squared. If you do that, you get x squared minus 2x plus 1. And of course, removing the 1 from here. The 1 looks stupid, but I'm leaving it there. I'm being stubborn. Anything raised to the first power is itself. Now, if you collect like terms right here, if you get all the terms together, you'll just end up with x squared minus x minus 12 in this large parenthetical expression right here. And it turns out that factors nicely to x minus 4 times x plus 3. Now, the whole reason we factor is so you can see the solution very quickly. You notice that if you put a 4 right here, this parenthetical expression is 0. 4 plus 3 over here is 7, but we don't care because we have a 0 right here, right? And then the same thing for the x plus 3. You change the signs precisely because when you put minus 3 in right here, this vanishes. All right, and so all it takes is one of these factored terms to be equal to 0 for the whole thing to be equal to 0. All right, now this one's not as hard as it looks. If you put 1 in here, you get 0. And 0 raised to any power outside of 0, of course, is 0. In other words, if you put a 0 there, that would say 0 squared, take the 5th root of 0, you get 0 back. So y'all, this is the solution set. I like this notation. You could write down x equals 1, x equals 4, x equals negative 3. I just like, I like the solutions to this equation are contained in this solution set. Hope you enjoyed that.